Hey everyone, today I'm going to talk to you about special right triangles. There's two steps to special right triangles, 45, 45, 90, and 30, 60, 90 triangles, which I go over in my other video. A 45, 45, 90 triangle is that if you do the Pythagorean theorem for a triangle with angles that are stated as 45, 45, and 90, then two of your sides are going to be the same, okay? So L is going to be the same as this L. And then your alongside or your hypotenuse, which is opposite of the right angle, has the square root of 2 next to it. This is the same number with the square root of 2 next to it. So this is what I mean. I have a 45-degree angle looking over here, which means this side is going to be 6. How did I know that? Well, this angle was 90. That angle is 45. So this angle is 45. So this is my L, this is my other L. So I'm looking for L square root 2. Well, if L is 6, then the answer is x equals 6 square root 2. Now, this might seem completely foreign to you, but again, everything is justified by the Pythagorean theorem. Over here on the side, I'm going to do the Pythagorean theorem with 6 squared plus 6 squared, and that's going to equal x squared, which was, I was looking for x. So this is going to be 72 equals x squared, which means x is going to equal the square root of 72. Okay, so this 72, we got to simplify that radical. This 72 is 36 times 2. Well, the square root of 36 is 6. The square root of 2 stays behind. So I get x equals 6 radical 2, which is what I wrote over there without really having to do any calculations. That's because I know my special right triangles. And it's that same pattern for every single 45, 45, 90 triangle. Okay? So this one I have 9 square root 2, 9 square root 2. So you might be confused because, whoops, only the long side is supposed to have a square root 2. So obviously I'm throwing in extra square root 2s to make it a little bit more challenging. If you have two of the same sides, these are both your L. So if this is L square root 2, I'm going to write this out as 9 square root 2 square root 2. Because I got to throw in the extra square root 2 from the definition of the side. Okay, so what does this equal then? This simplifies right here. If you square root 2 times square root 2, that's squaring the square root of 2. That's just going to get 2. So I'm going to get 9 times 2. So in other words, the answer is 18. All right? So in essence, all I did was I took 9. If I notice both of my short sides had a radical 2, I just doubled the front number. So 9 times 2 is 18. So if I'm looking at, which is a good one? C. I know the answer is 14 based on that pattern. Now, I'll go over it. 45 degrees, going to look at the L side. This 45 degrees, going to look at the other L side. 7 square root 2. So I have 7 radical 2 radical 2. Okay, because this is the L, and that's the extra square root 2. So if L square root 2 is this turns into 7 times 2. That turns into 14. All right. Part C. I know this is 9. So 45 is looking, whoops, not over there. It's looking there. That means this is also 9. So I have 9 square root 2. One of your sides will definitely have a square root of 2 with it. The reason why these two had a square root of 2 with it, I had 2 of them, and this one only has 1, is because the long side is your square root of 2 side. So if that is a whole number, then the other 2 sides will have a square root of 2. If it is not a whole number, then it's going to have a square root of 2, and your whole numbers will be the 2 L's. All right. In this example, I have 4. This is 4. The hypotenuse is L square root 2, so this is 4 square root 2. In this example, I have 5. The answer is 5 square root 2. See, this is so much quicker than trying to do Pythagorean theorem with all this stuff. Now, in these next couple of examples, I make it a little bit more challenging, but I'm basically going backwards. See how I had 14 was a whole number, and the answer was 7, or the little sides were 7 square root 2. I had 18 for a whole number, and the little sides were 9 square root 2. So, you should be asking yourself, if this is 12, what are the answers? What's the other one going to be? And so you might be thinking, oh, it's 6 radical 2. Now, I want to be able to explain this to you about how I went backwards so quickly. This is my L square root 2 side. So that is L, some number L, times the square root of 2 equals 12. So you can think about it like this. L square root 2 equals 12. Okay, if I divide out square root 2, I get 12 over square root 2, which doesn't look like 6 square root 2. Oh, I'm skipping ahead. But it doesn't look like this. I had written 9 radical 2 radical 2. So, no. I'm just losing my train of thought. 12 divided by the radical 2 is 6 radical 2. Now, why is that so? That is because I had to rationalize this denominator, which means this makes 2. So I have 12 radical 2 over 2. The bottom makes 2. And 12 over 2 equals 6. So yeah, this is called rationalizing a denominator, because you don't want a square root in your denominator. So the reason why I did square root of 2 over square root of 2 is because that's like a multiplying times 1. All right. Now that may confuse you. If it didn't, great. Then you're getting all of this then, hopefully. If it did confuse you, I like to think of it like this. 12 is my L square root 2. I need to make it look like that. So if I divide 12 by 2, that's 6 times 2. And the reason why I divided it by 2 is because 2 kind of looks like the square root of 2. I can make the number 2 look exactly like the square root of 2, because if I use, what are my factors? I need to use the square root of 2 as a factor of 2. 6 times square root of 2 is 6 times 2. It's the same logic as up here when I did 9 square root 2 for L square root 2, because I was given this, the L 9 radical 2 for my L side, and I threw on an extra square root of 2. Since I'm going backwards, it's the same thing. This will have an extra square root of 2. So reading this from right to left says 6 times the square root of 2 equals 6 times 2, which equals 12. Okay, so I ended up right where I started. Now, how does this help me figure out my other side? Well, this is going to be the L, and that'll be the extra radical 2 for the L radical 2 side. So if this is just the L, then this is what I was looking for, which is what I had started off with, because I figured out the pattern. So if you figure out the pattern, then you don't even really need to go through all of this, because the special right triangles are supposed to save you time. Okay? So this one's actually not that difficult, because this one is the L square root 2 side, because it's opposite of the right angle. Well, if this is the L square root 2 side, then L is 5, so x is 5, x is 5. I didn't have to go through all that stuff for this one, because I was given what it's supposed to have a square root of 2 with it, so I just had to take that number by it. Okay, a kite string. It is 220 feet long from the kite to the ground. So I'm going to put 220 next to the kite string. The string makes a 45-degree angle with the ground, and about how high off the ground is the kite. So I'm looking for this. All right, it's the same kind of problem as this one, or this one, or this one, because I'm given a whole number for the hypotenuse. So I'm going to cut it in half. 220 is 110 times 2. 110 times 2 is 110 square root 2 square root 2. That's my L. This is the extra square root 2 because this was my L square root 2 side. How did I know that? Well, if this goes straight down, then that's going to make a right angle. The right angle always looks at the L square root 2 side. So I just figured out that this is 110 square root 2, this is 110 square root 2, which is the answer. Again, what's the pattern? I was given a whole number for the long side, so the short side is half of it with the square root of 2 next to it. Okay, got a couple more examples. 18, I'm going to cut it in half, throw a square root of 2 next to it. The answer is 9 square root 2. The answer is 9 square root 2. If you want the long explanation, here it is. 18 is 9 times 2. I'm trying to make 18 look like the L square root 2 because it's that side. So 9 times square root of 2 square root of 2 is 18. So this is my L. This one. This was L radical 2 again. So L is just 17. The answer is 17. It's really easy when I give you a problem set up how it's supposed to be. This is as difficult as it's going to get for 45, 45, 90. Now, you hear this problem is a baseball diamond is a 90 foot by 90 foot square. So I'm going to try and draw a square that looks kind of like a baseball diamond. If it's 90 by 90, that means every single side is 90 because it's a square. All right. Home plate, first base, and second base form an isosceles triangle. So go from second to home. Draw a line. And first base, we have a right angle now. Find the distance that the second baseman, this guy, or gal, we'll throw to this guy, gal. So am I looking for the L side or the L square root 2? Well, I know these two are 90, so those must be L's. Also, it's opposite of the right angle, so I'm looking for L radical 2. Well, this is L, that's L. L radical 2 is just 90 radical 2. And that's it for 45, 45, 90 triangles, all right? Hope this helped. Thanks, bye.